Getting into shape. Skill 9, the stars align. Volume of prisms. Units of volume apply to finding out how much space fits inside an object. Units of volume are always three-dimensional, so you need to write all units to the power of 3. There are two ways to find the volume of a 3D object. The first method is to use a specific formula for volume, and these are shown below. We have the volume formula for a cube, V equals length to the power of 3. Volume for a cylinder, volume equals pi times r squared times h, where h is the height of the cylinder. Rectangular prism, volume equals length times width times height. And volume of a triangular prism, where the volume is half times base times height times the prism height, or length if you want to look at it like that, but it's the distance between the front triangle to the back triangle for the capital H. Capital H also appears here on the rectangular prism as the height from the bottom to the top. Capital H appears on the cylinder, the distance between the bottom circle and the top circle. The height of the cylinder can come in quite handy because it works with us for another way of finding the volume. This is method 2. In method 2, we can multiply the cross-sectional area by the height of the prism, recognised by the capital H. We'll go into an example of that in another slide. Here we're going to look at some examples of finding the volume using a formula. So this is method 1. Down here we've got a triangular prism, and here's a triangular prism example. We've got 3 centimeters, which is the height of the triangle, 4 centimeters is the base length, and 8 centimeters is the height of the prism. So we substitute these 3 values into the formula. Here's the formula on the right, and here are all the values substituted in. V equals half times 4 times 3 times 8. And that gives us a volume of 48 centimeters cubed. A cylinder example is on the right, and here is our big cylinder. We've got 2 lengths. We've got a diameter of 5.4. We know it's the diameter because it goes all the way across the circle. And we've got a height of this cylinder of 3 meters. Because we've got the diameter, we need the radius, so we halve it, and we get a radius of 2.7 meters. We apply the formula, V equals pi times r squared times h, pi times 2.7 squared times 3, gives us a volume of 66.71 centimeters cubed. So when you're using a formula, it's really important to make sure you substitute the values in correctly. And if it's a cylinder, it's extra important to make sure you're using the radius length and not the diameter length. The second method of finding the volume is where we multiply the cross-sectional area by the height of the prism. An example of the cross-sectional area is the shape that appears at the front and the back, or the top and the bottom. In the case on the left, we've got a pentagon, alright, or a pentagonal prism. Here we can see the pentagon shape on the bottom, alright, and the area is represented by the shaded blue section. If we know the area of this section, we can multiply it by the height length, and that'll give us the volume. An example of this is on the right hand side with a hexagonal prism, where we've got a hexagon shape at the front of the prism and also at the back of the prism, as you can see me drawing in there. These are joined by a line of 8 centimeters length. That means that the height of this prism is 8 centimeters. Okay? The area of the hexagon at the front, the shaded blue section, we can see underneath is 40 centimeters squared. So our general formula for this is area times height. So we do 40, which is our area, and we multiply it by 8, which is our height. And that gives us an answer of 320 centimeters cubed. This method can be quite useful if we're trying to find the formula or the volume of shapes which don't have a normal volume formula. And that's it. Skill 9's done. Splash!